Welcome back to geometry. We are at 2.4, reasoning and algebra. This section starts us off with proofs. And most of the proofs that we will do today will be proofs for algebra. And then at some point in time in the near future, we will transition to proofs in geometry. So the first rule, the first reason that we have is called the addition property. And when I think of the add property, we do it all the time in algebra. For example, you had x minus 4 is equal to negative 8, and you want to do solve for x, you would clearly add 4 on each side. Okay, and so what allows you to add 4 on each side is called the addition property. And so we have here in our notes, you can add the same number on each side. We can do the same with the multiplication property. I'm going to change this problem to an easier one. Let's change it to y over 2 is equal to 6. And if I want to do solve for y, I would times 2 on each side. And when I times 2 on each side, just like over here when I added 4 on each side, except now we're not adding, we're going to times each side by 2, that's known as the multiplication property. So we can times each side, or you can multiply the same number on each side. We can also do the same for the subtraction property. Again, I'm going to change this problem to an easier one without fraction. Let's say x plus 5 is equal to 3. We can minus 5 on each side, and when I subtract 5 on each side, that's known as the subtraction property. And we can also do the same for the division property. Again, I'm going to change the problem. We're going to get rid of that. Let's call it 2y is equal to 12. And I can divide both sides by 2. And when I divide both sides by the same number, that's known as the division property. Okay, next term we have is the distributive property. And that means that A multiplies everything inside the parentheses. So A is on the outside, A is going to multiply all the way through. A times B is AB, and then A times C is the AC. So what it looks like when we solve a problem in algebra, again, I'm not allowed to say that 1 plus 2 is 3. Okay, I first have to times 2 all the way through. And that's using the distributive property. So that 1 plus 6x minus 2 equals 3x, and then distribute this negative sign through, minus x, negative times negative is positive 1. Next, from here, we must combine like terms. So that's going to give me 6x, and that's going to be negative 3 equals 2x plus 1. And then solve for x, we end up getting 4x is equal to 4, x is equal to 1. Next, our substitution property. If a is equal to b and a is 3, then 2a plus 1, I can substitute in 3 for a, and that would give me 7. The other thing that's important to note is that this should be highlighted in your notes, because when we combine like terms or simplify, that's now called substitution. Okay, so if I were to solve this problem, I would get 3x to the fifth plus 4x squared, and then let's simplify or combine like terms, and then plus 2x. And what allows me to do that is called substitution, even though what we really did was we just combined like terms. So we're going to do our first proof right now, and we're going to have a statement column and a reason column. So anytime that we do a proof, we must, or not must, but usually it's done in a two-column proof. So we have statements and reason. All right, and our first statement is always going to be given to us. And so we're going to take this problem. We have 1 plus 2 times 3x minus 1 minus 2 equals 3x minus, and then x minus 1. Alright, from there, we're going to then use the distributive property, and we get 1 plus 6x minus 2 minus 2 equals 3x minus x plus 1. And so the reason for that, or what we just did, we used the distributive property. Okay, next, on statement 3, we must combine like terms. So we end up getting 6x minus 3 equals 2x plus 1. Now, the reason for this, even though it's called combining like terms or simplifying, the rule that I have to use is substitution. And maybe in parentheses, let's put combining like terms. And that's also known as simplifying. Alright, from here, there's a few ways that I can solve for x. Well, one way that I can do this, let's change the pen color. Let's go pink. So let's go and add 3 on each side. So when I add 3 on each side, I get 6x equals 2x plus 4. Now, my reason for this, what allowed me to add 3 on each side? Well, that's the addition property. I'll just put add property. Alright, then let's minus 2x on each side. And so when I minus 2x on each side, statement 5 is going to read 4x is equal to 4. And what allowed me to do that? Well, the subtraction property or sub property. Alright, then let's divide each side by 4. So if I divide each side by 4, statement 6 is going to say x is equal to 1. And what allowed me to do that? The division property. Now I'm finished from here because I have x is equal to 1. We just did our first proof, even though this was an algebra proof. The next property that we have is called the symmetric property. With the symmetric property, we can say that if A is equal to B, then B is equal to A. Where have we seen that in algebra? Well, if our answer was x is equal to 6, the answer could also read 6 is equal to x. So if segment AB is congruent equal to segment WB, then I can say that segment WB is congruent equal to segment AB. Back with algebra, if 2x minus 1 is equal to 13, then 13 is equal to 2x minus 1. For angle K, we can say that angle K is congruent equal to angle K. I can say that x is equal to x. Sorry, not x is equal to 6. Excuse me, x is equal to x. I could say 6 is equal to 6. And so the rule here is any number is equal to itself. The next property is the transitive property. And we use this proof a lot, or we use this property a lot in geometry proofs as well. To start this off, when we think of football, and we were to say that San Diego Chargers beat Seattle, which we did, I think it was in week 3 this year. And then Seattle then were to beat, let's say, Denver. Then by the transitive property, San Diego, since we beat Seattle and Seattle beat Denver, San Diego should beat Denver. Well, that didn't happen this year, but in theory, using the transitive property, it should. So what we're really saying is if A is equal to B and B is equal to C, then A is equal to C. Or if angle 1 is congruent equal to angle 2, and angle 2 is congruent equal to angle 3, then angle 1 is congruent equal to angle 3. Also, one thing to note is that transitive property let's see, let's draw this arrow down to here. This is a form of substitution. And why is that, you may ask? Well, if angle 1 is equal to angle 2, and angle 2 is equal to angle 3, I substitute angle 1 so that it's equal to angle 3. So that's a form of substitution. Working down below, these are easier type problems. We have in algebra problem 2x minus 3 is equal to 8. Clearly we're going to add 3 on each side, get 2x equal to 11. This is the addition property. Next we're going to use the distributive property. And how so? Well, we have to multiply negative 2 all the way through to get negative 6n plus 16n. On problem C, we must divide both sides by 13. And when we do that, we get 3 is equal to y. The division property. Problem D, 2x minus 3 is equal to y, and then they substitute in 6 for y. This is going to be the substitution property. Alright, I always like to star or highlight problems that are challenging. And I think this is our first challenging problem with these. So the reason being is, how do we go from 2n plus 3 and minus 6n plus n, and then how do we go from here to get to here? Well, we must combine like terms. However, when we combine like terms in geometry, that's now called substitution. So I have the star here because I think this would be one that some students might miss, because it's really just combining like terms, but that is now called substitution. If d is equal to 3 and 3 is equal to z, this looks like the symmetric property. And how do we go from 4w plus 7 is equal to 10 to this? We minus 7 on each side, minus 7, minus 7. So that's the subtraction property. Alright, we have a proof here, and again, the proof will always be given to us. So we have our first statement, which is the actual problem itself, and then that reason is always given. How do we go from statement 1 to statement 2 will be our second reason. So this 2 multiplies all the way through. That's known as the distributive property. Next, what should we do from here? Well, there's a few things we can do. I think we should first combine like terms. So negative 4x plus 6 equals 16 minus x. And when we combine like terms, that's called substitution. From here, there's a few different ways that we can go. Let's add x on each side. That gives me negative 3x plus 6 equals 15. And that's the add property. Now, if you were to minus 6 first on each side, that would work too. Okay, so there's more than one way that you could do this. You could say, hey, I'm going to subtract 6 on each side. That would leave me with negative 4x equals 10 minus x. And so if you did it that way, you know that you would use the subtraction property. Alright, and from here, let's minus 6 on each side. Negative 3x is equal to 10. That would be the subtraction property. And then divide both sides by negative 3, x equals negative 10 thirds, and that's the division property. Next proof, we have negative 3 times 4 plus n equals negative times n plus 3 plus 7. Note on the reason, they did not give us a reason. So when they don't do that, that's fine. We'll just enter our own reason. This problem was given to us. Next, let's multiply negative 3 all the way through using the distributive property. And that would be negative n minus 3 plus 7. Distributive property. Next, alright, from here, let's add m, or excuse me, let's combine like terms. So negative 12 minus 3m equals negative m plus 4. So we have to use substitution. And again, that means combining like terms. Next, let's add m on each side. Negative 12 minus 2m equals 4. And that's the addition property. Next, let's add 12 on each side, and that gives me negative 2m is equal to 15. Again, that's the addition property. And then divide by negative 2 and equals negative 8. Division property. We have now made our way to our first geometry proof. So here we have a segment AB, which is 3x, and segment BC, and we are given that segment AC is going to be equal to 36. So it's always smart to kind of think of a plan that we can use to solve what we're being asked to solve. Now we're asked to solve for x. So in a sense, we know that this segment plus this segment is going to equal 36. So now we have to put this plan into a two-column proof statement and reason. And we have to list all of our steps. We can't leave anything out. So the first thing that I want to say is, I want to say that AD plus BC is going to equal AC. And actually, we should put segments here. So segment AD plus segment BC is equal to segment AC. Now, what allows me to say that AD plus BC is equal to AC? Well, that is the segment addition postulate. All right, next, in this problem, we can see that AD is 3x. So let's substitute 3x in for AD. Let's substitute 2x plus 1 into BC, and let's substitute 36 in for AC. So clearly, that's the substitution property. From there, we're going to combine like terms, so 5x plus 1 is equal to 36. And again, since we combine like terms, that's called substitution. Minus 1 on each side, 5x equals 35. That's going to be subtraction property, sub-property. And then divide by 5 on each side, x equals 7. That's known as the division property. Next, we have what's called a vertical angle theorem. And here's what we want to say with that. We want to say that angle 1 is congruent equal to angle 2. So angle 1 is congruent equal to angle 2. And angle 3 is congruent equal to angle 4. Because we know that vertical angles are always congruent. Angle 1 and angle 2 are considered vertical angles. Angle 3 and angle 4 are also considered. Next, we have our congruent supplement theorem. And what we're saying here is that if two angles are supplementary to the same angle, then they are also congruent to each other. So let's draw a quick picture of that. Let's draw our angle. Let's draw our straight line. And then let's draw a second straight line. And let's say that we have a 120 degree angle here. Then that means that this angle over here has to be a 60 degree angle. I mean, this angle over here also has to be 60 degrees as well. So if two angles, meaning angles 60 and 60, are supplementary to the same angle being 120, then they're also congruent to each other. And angles, these two angles would each be vertical angles. Alright, next we have if two angles are complements of the same angle, then the two angles are each congruent. So let's make this drawing. We'll draw a 90-degree angle. We'll put it off. Let's also draw a second 90-degree angle within the first 90-degree angle. And we'll put a box here as well. And so what we're saying is that if this angle formed in here is 48 degrees, that means this angle must be 42 degrees, and this angle must also be 42 degrees. So it's similar to the same theorem that we had over here where these two angles were supplementary to the same angle. These two angles, angle 42 and 42, are both complementary to angle 48. And so that's why these two angles are the same. Alright, then our last theorem that we have down here is that if two angles are both congruent and supplementary, they are right angles. So again, let's draw a line. Here's our line. And let's create two right angles. And so we're saying that if two angles are both congruent and supplementary, so they are now each congruent with the box, and then they are also supplementary because 90 plus 90 would give me 180 degrees, so that satisfies both of these. And they must be right angles. And then furthermore, we would know that all right angles are each congruent because all right angles will have a measure of 90 degrees. Alright, to the algebra review. Are each pair of lines parallel? And this is our sign for parallel, this is our sign for perpendicular and upside down T. Or will it be two lines that just intersect once? Okay, and so that's what we have to decide. Now, we should solve all these without graphing. You can graph if you want, but really, we need to just look at our slopes. If our slopes are the same, that means the lines will always be parallel. So same slope means that the slope is parallel, or that the lines are parallel. If the slopes are opposite reciprocals, then the slopes or the lines will be perpendicular. Now, an example of what a opposite reciprocal would look like. Well, if you take 1/4 and -4 over 1, the signs are opposites, and 1/4 and 4 over 1 is considered a reciprocal. So 1/4 and -4 over 1 would be considered an opposite reciprocal. And then if the two lines intersect just one time, that'll be anything else. So if they're not the same and they're not opposite reciprocal, then that means that they will intersect once, and that will be everything else. On problem 1, these slopes aren't the same, they are not opposite reciprocal, so this would be intersecting 1. So we'll put intersecting or intersect 1. Problem 2, these slopes aren't the same, one's negative, one is positive, and these slopes are not opposite reciprocal. So just like in problem 1, these lines intersect 1. Problem 3, 4x or 4 and 4, these slopes are the same, so we can write parallel. Problem 4, sometimes it helps to graph. If we graph y is equal to 2, we have a horizontal line, and then y is equal to 3, another horizontal line, and these lines have the same slope of 0, so since both slopes are 0, we want to write parallel. Number 5, one's positive, one's negative. these aren't the same, they're also not opposite reciprocals, so they intersect once. Alright, then last, these slopes aren't the same, but they are opposite reciprocals, so these two lines are perpendicular. That's all for this round.